Hey, in this video, let's come up with some higher order functions and demonstrate them in C++. So I'm in Visual Studio and I want to first include our container header, so a vector, and that special other header, functional. That'll give us access to the standard function type. Alright, so now I can start writing a higher order function. Let's try this one. Apply to vector. So let's make a function that's like, it takes a vector. So let's just do a vector of integers for now. And it takes a function. So function, and let's say it just takes an integer and does something with it and returns void, so we don't get any result out of it. So let's just make this function kind of go through this whole vector and call the given function on every element. So alright, something like that to loop through it. There's technically, this is a size t, it returns, it's just unsigned, alright, whatever. And let's call that function. So f is the function we're calling, and it needs to be called on every element of v. Alright, so we're just calling our function many times, passing at each sequential element of our container. Not too crazy, but what this means is that we can make any sort of function and apply it to every element of this vector. Let's try some. So apply to vector. We need a vector, so let me create one. Vector of integers. Let's just come up with some arbitrary numbers there. Alright, now apply to vector v, and then we need a function to apply. So let's create one. Alright, so this is, it has to take an integer. Alright. The return type can probably be left implicit, and it's not going to return anything. And let's see, let's do like printing it out. Print out A. Let's do that. Let's try running it. And so it has applied to vector that function that just prints out the integer and applied it to each element of this vector. Alright, we can break that up, put it on other lines, just a small change. Alright, yep, one on each line now. And now let's try this with a little bit of a different function, a different lambda function here. Let's make a copy. Let's try that. Let's make another vector, and then let's apply to vector. This is not a good way to copy a vector, by the way. This is just doing it a crazy way. So let's say apply to vector. We'll use vector v as our input, and for every element of vector v, let's try storing it in the other vector. This is silly. Alright, we don't have access to the other variable in this function, so we have to capture it. You can capture by reference so that it actually gets changed and modified when we use pushback. Alright, now that we have that, let's print it out. Make sure we're printing out other. Okay, so it repeats itself, but let's make sure that that's actually working here. So let's do like a plus 4. So it'll copy the vector, but add 4 to each element that it copies. Alright, yep, there it is. Cool. So that's all plus 4. Great. Alright, so that's one kind of higher order function. Could be useful, depending on what you're trying to do with it. Let's try another one. Let's try one that returns a function. So there might be cases when you have a function that's just like we have here, where it returns void or whatever, but maybe you want it to return a Boolean. It's just what you're given, and this is something that you can kind of a pattern referred to as function adapters. So I'm going to just say adapt to return bool. Alright, so we will accept a function that returns void, and we're going to make it work a little differently. We're going to make a new function that returns Boolean instead, but kind of does the same work. So let's say return, let's make a new lambda, and the bulk of it is that it's going to, well, it has to call that function, has to call it on an integer, so we need an integer here. That's my integer it's called on. And that function has no return type, so this is fine. But we want it to have a return type. So let's say return true. Just, that seems fine. And f needs to be captured in order to reference it in this function. So let's capture it. Alright. So adapt to return bool is pretty much just changing the signature of a function. Instead of returning void, it's going to return Boolean. It's always going to return true, so this isn't the most useful adapter. But if you run into a situation where code is expecting a Boolean return value, it's not going to accept a void returning function. So let's see, can I do something like that? Alright, test return bool. Okay, so we have a function requirement here, right? And we don't really care what it actually does. Test return bool. Okay, let's just do that. So it doesn't do anything really special. I'm just giving it some sample value to work with. So when I go to use this, then I need to call test return bool, and I need to give it a function that has a Boolean return type. Let's say I have a function that does not have a Boolean return type. Bad function. Okay, so bad function does something, maybe something useful with that value, but I can't call test return bool with it. Bad function. Because it doesn't return the right type. But I could use this crazy adapter here, adapt to return bool, to change it, make a new function. That does the same thing as bad function, but returns a Boolean, and now I can actually pass it to that function. So, a little crazy, but it works. So those are some examples of using and creating higher order functions, and I'll see you in the next video.